Hi guys, quick lesson on the sine rule. So obviously when you're dealing with right angle triangles, we use Pythagoras' theorem or trigonometry SOHCAHTOA. But when we go on to non-right angle triangles, we have to look at two different rules, and the first one is sine rule. Okay, so in sine rule, what you have is you've got a non-right angle triangles, and the reason you use sine rule depends on what information you're given. Okay. So before we discuss what information we're going to be given, I just want you to quickly look at this non-right angle triangle. Okay, so if we look at the angle B, the side directly opposite it is called little b. Okay, so these two here are a match. Okay, the angle C, and we normally represent angles with capital letters, and then the side across from it is the small letter. Okay, so they're a match, and then capital letter A for the angle is across from the baby A. Their match. Okay, so that's the first thing that you need to know about your triangle. So when you're labeling one angle, the side opposite it would get the smaller letter. Okay. And then from the sine rule says that A over sine A is equal to B over sine B is equal to C over sine C. And that's what we can take away from that. We can also actually flip this rule. So I can say that it's sine, sorry, I need a pen. So I can say that sine A over A is equal to sine B over B is equal to sine C over C. So the only mistake that you can really make is if you match them up incorrectly. Okay, so please make sure that capital letter B goes to the side opposite it, etc. Okay, so from here we have to think about what we need. So generally we only use two fractions together, or two ratios together, so A over sine A and B over sine B, or B over sine B and C over C, etc. Okay, so we normally only use them in pairs, so you could use this one, or you could use the A and the C together. That's completely up to the information that you're given. Okay, and we normally use the reverse of it, so the flipped version, when we're trying to find the angle. So my angle is on the top here, whereas my side is on the top here, so I'm trying to find my side. And yeah, so this should tell you then, if you're using these four things here, you're going to be given a side and the opposite angle, and another side and the opposite angle. Okay, so that's what tells you that you're using the sine rule. So if you've got the opposite angles to the sides and you've got two of them. Okay, right. So now let's put that into practice. So the first example, I'm trying to find the length of P, which means I'm trying to find the side, I'm trying to find P. Okay, straight away I can see that I'm given the angle opposite it, and I'm also given 95 and the angle opposite it. So these are the matches, these are the pairs. I always draw arrows and stuff like that just so I don't make mistakes. Okay, I could have been told this angle here instead of been given maybe the 32, so they didn't need to give me the 32. They could have given me this angle, and then I could have done 95 plus this angle and taken it from 180 to get the 32. Okay, so again, I'm going with a basic example here, but don't be afraid of it if you see this angle, because you can just work it out to get the 32. So again, I'm trying to find my side, so the formula that I'm going to use is here's my pen, A over sine A is equal to B over sine B, and then I can plug in what I know. Okay, so I know that I've got P over my sine of the angle opposite it, so that's 32 degrees, is equal to 21 over the sine of 95 degrees, that's the angle opposite 21. Okay, I'm keeping my P over here because that's the one that I'm trying to find, and I want my answer to look like P is equal to something. Okay, so back to my pen, I'm going to cross multiply, so I'll just change colour, cross multiply, and I'm going to do my P times my sine 95 degrees is equal to 21 times my sine of 32 degrees, and P is equal to the 21 times the sine of 32 degrees, and because I was multiplying by sine 95, I'm now going to bring it over and divide by sine of 95. Okay, and you can put that all into your calculator at one time using the fraction button, and you get an answer of approximately 11 units. So it comes out as 11.17, but when you round it you get 11 units. Okay, I hope everybody can see that. I'm just going to write it in a different colour pen. So P is equal to 11 units. Okay, and that's my first answer. So just quickly, I just want to remind you, the reason that I'm using A over sine A and B over sine B is because if I keep my side or the unknown on top, I just have less algebra to do. Okay, that's all it is. You could, if I'm trying to find an angle, I can still use this formula, but I'll have to just rearrange it again to get the angle on its own. Okay, the next example, in this example here, I'm trying to find my angle. Okay, so because I'm trying to find my angle, I'm going to use the reverse of the formula. So I'm going to do, instead of writing it out, guys, I think we all recognise what it is. So it's the sine of B, and I know that it's done with a small letter this time, but don't let that scare you, just follow the rule. So it's the sine of the angle all over the side that it's opposite, and then it's sine of 100 degrees, and the side that it's opposite is 5.1. Again, if I was given this angle here, I could still, well, actually this time I'm trying to find the angle, so that same rule doesn't apply. Never mind. Okay, so then I'm going to do sine B. So again, what I'm doing here is I'm cross multiplying. So I get my sine B times the 5.1 is equal to the sine of 100 times 3.6, and isolate my sine B degrees is equal to sine of 100 degrees times 3.6, all divided by 5.1. And again, because I'm trying to find an angle at this section here, I'm trying to find an angle, so in order to find the angle I have to do B degrees is equal to the inverse of that trigonometric function. Okay, so sine of 100 degrees times 3.6 all over 5.1. Okay, one little tip that I wanted to give you, so I wrote it like this on purpose. Okay, you might want to put in brackets around your 100 degrees. It's really, really important that you don't do the sine of 100 times 3.6, i.e. 3,600. Okay, you don't want to do, sorry, not 3,600, 360. So you don't want to do the sine of 360, you want to do the sine of 100 degrees multiplied by 3.6. So make sure that you've got that written down correctly, and when you do that in your calculator you get B is equal to 44.0398, which is approximately 44 degrees to the nearest degree. Okay.